Hello, my name's Dr. Phil Winder. I forgot my name then. So welcome to today's talk. Hope you're well. So a couple of quick things just before we get started on this presentation. This is a presentation all about supply chains that I did at a conference last week in Nice. It's quite interesting, quite short. Hopefully you should find it entertaining. So quick admin, if you've got any questions about any of the content, then please type your questions away in the comments section of the platform that you're using, and then I'll get to see them in the platform I'm using here. I'll probably try and answer them at the end if that's okay. But yeah, do type them in because there is a bit of a delay in the feed here. So don't wait until the end because I might miss it. So quick recap of what we do, just in case you haven't seen any of my videos before. So I am an AI practitioner. I have a business called Winder AI. We specialize in providing professional services, so like development services and consulting services around the use of AI. We build out AI applications, AI products, AI platforms, and that kind of spans a few technical disciplines like reinforcement learning, machine learning, MLOps, and things like that. And this talk today is going to all be about supply chain. So let's bring up the slides, and you should be able to follow along with this. So the goal of this presentation is to provide you with a bit of insight as to the impacts that AI is having in the use case of start again. So this presentation is all about the impacts that AI is having in the supply chain. So it's a variety of use cases that are possible throughout the supply chain. And so I'm going to try and hone in and focus on a couple of those and provide you with a bit of inspiration about how AI could be used. So let's go. The presentation split into 4 sections. I've got a section on why AI matters. So basically why now, why AI. I've got a section on what AI can do, the state of the art. And so there I'm going to be talking about use cases. How it's achieved, this is more a section about how some of these technologies work, how they do their job. And then finally, what else to look for. what to look out for. This is a couple of tidbits that I've created over the, that I've learned over time to help me figure out what is a good AI use case and what is not. So hopefully it'll help you find use cases within your business. Okay, let's get going. So one of the main drivers really of the AI, the prevalence of AI in projects today is financial. And so I decided to, since I was speaking to predominantly sort of finance professionals in the conference last week, I decided to focus on the financial aspects. Obviously, there's potentially other avenues you could go down, but fundamentally, most improvements provide a financial benefit. I've split it into 4 boxes here just to kind of demonstrate the breadth of the use cases that are possible within a business. And they're split into 4 different boxes. So at the top, we've got cost reduction in various parts of the businesses. So this is where we try and apply AI to optimize or automate processes, maybe optimizing the inventory that you might have. And logistics is a classic example there. It could be focusing on improving cash flow within a business. So there, I mean, improving access to capital. Maybe it's improving fulfillment. So if you can fulfill your orders faster, easier, quicker, cheaper, then that reduces your costs. Maybe it's turnover. So simple things like accounts payable automation or contract analysis. That can affect the delays that may occur in the processing of orders or the turnover of orders. It might also be for risk mitigation. I know there's quite a few companies now that are involved in the definition of supply chain risk. And for them, there's a particular focus on attempting to identify and detect various aspects of risk within the supply chain. Supplier risk. So for example, if you have a fairly complicated supply chain and some people within that supply chain are facing difficulties, then it could affect you. If you can detect that early, then that's great. Demand volatility is probably an issue for most companies. If you have a wide swing in demand, then you could either be overstocking, understocking, too many staff, not enough staff, too many staff, things like that. And so if you can better predict that volatility, that demand, then great. Financial risk. Yeah, if you've got money coming in from various places or money going out for various places, if there's any risks related to the movement of that money. So for example, if a business goes bankrupt or something, then you need to be aware of that. And then finally, revenue growth. So this is the area where companies are focusing on building products and services in order to expand or take advantage of new opportunities. So, for example, if you are building or innovating in new products, you could be building AI products to fuel innovation. Demand and service sides as well can all benefit from that. So lots of different areas of the business, and that probably isn't even exhaustive. I just kind of wanted to demonstrate that that it is possible to apply AI to nearly all of the business. But let's focus on one particular one. So the cost reduction element. Even then, we can start splitting that into ideas for the use of AI. So I talked a little bit about inventory. So reinforcement learning in particular is used quite heavily for inventory management. So the placement of inventory around a warehouse, for example, could be optimized based upon the paths that people are taking to get the items in the inventory. Scheduling is another one. If you've got an industrial process that requires various steps or phases that need to be scheduled in a certain particular order, but machines are busy and take time to work, then again, you've got an optimization process there. Heading towards just-in-time manufacturing, production, etc., etc. On the process side, that's probably a bit more traditional. I'm just going to quickly check that message. Oh, yeah, nothing. On the process side, this is a little bit more traditional use of AI, potentially. So back office automation, product automation. And yeah, other sort of traditional forms of automation there, which obviously software plays a huge role as well. And then logistics. This is probably the classic use of AI to optimize parts of the cost reduction in supply chains. So here we're thinking about attempting to improve the routing of delivering products, physical products, but maybe it's not just in delivery in like physical product businesses as well, like in service-based businesses. There's an analog here, an analogous kind of process for like pricing. If you're attempting to optimize the pricing when you're delivering your products, that could be an area of optimization, scheduling and planning again as well. So yeah, overall, wide variety of potential use cases that could be solved with AI. So let's take a look at a few particular ones in detail, just to give you a bit of an indication of how AI is changing the way that we do things. So this is a picture of a traditional forecasting process for inventory management. So the whole goal here, the whole idea here is you only want to, and we're talking about a physical business again, a physical product-based business. You only want to manufacture the right number of widgets or parts. You don't want to produce too many, because then you'll just have waste. You don't want to produce too few, because then you won't have enough to sell. You'll be missing out. There'll be an opportunity cost there. So ideally, you want to get it just right, Goldilocks in the middle. Traditional forecasting techniques use a very I was going to say simple, but they're not necessarily simple. They can be quite sophisticated, but a fixed statistical model to base the predictions upon. And then this statistical forecast is then often tinkered with or mutated by humans to decide whether that forecast was appropriate or not, maybe to include some extra domain expertise, maybe some extra knowledge that the statistical model isn't aware of at the time. And then you end up with an adjusted forecast. That adjusted forecast is then used for the production planning purposes, and that's the number that goes out to the factory floor. Later on, the actual result will come in and an error will be calculated. That error is typically incorporated into this process via the human. It's not often that this statistical model will change, but it potentially could. Okay, so that's a traditional method of demand forecasting, fixed statistical model, human interaction, and then you get the result. When you look at this in more of an AI approach, oh, hang on, we're just going to check. 2 seconds. I've just got a few issues with some people saying I can't see anything on LinkedIn. Let me just actually check the LinkedIn link to see if I can see view on LinkedIn. Oh no. Oh dear. Seems to be a problem with LinkedIn. Oh, right. Let's view on YouTube instead. Let's see if that's. Yeah. Yes. All right. So I think that's fixed. Yeah, that's really frustrating. LinkedIn has just got a spinning. It's just spinning. It's kind of started, but not continued. Well, I have never ever had that before. So apologies to everyone that was trying to watch on LinkedIn. Hopefully you can, rewatch the YouTube, or you can catch up with the video later on as well. I will also release this as a video. Yeah, I'll just mention that on the chat. All right. Well, welcome back if you just joined me on YouTube. I hope you've had a moment to catch up. So I've just been recapping a traditional forecasting process. The next part, so the AI impact on this process is that rather than using a statistical model, we can now use our data that we've generated for our specific use case to train a model, or maybe not even train a model from scratch. It might be just taking the statistical model and adapting it or improving it, maybe tuning the statistical model instead. You can kind of view it as a process of trying to improve that initial model. And that all uses the data to do that. We can train the model, and we can also incorporate human elements into that model if we want to. But the crucial thing is that we can do this in a fully automated, closed loop system. So we can actually make the prediction, see what the result was. If there was anything wrong in the actuals, based upon if there was any difference in our prediction against the actuals, then we can feed that back into the next training run and then build a new model and so on. Purely, fully continuous process. It's called continuous learning. So the net result is a much more automated model, a much more robust model, because you can actually quantify how wrong you are. It's also more automated in the sense that you don't have to have the human input in order to generate the report now. You can just leave it, it'll keep running and keep going. So this scales really well, whereas the previous one might not. It also should result in better performance because you're training a model that is specific to your business, and that the statistical forecast is probably not doing that. So yeah, range of potential improvements there, and that is an actual example. So another thing that is becoming increasingly important for risk management companies is exposing your data, actually showing your data to users so that they can actually either use that data in some way or make decisions upon it. So that's the word analytics. Analytics here means exposing data, exposing information for people to use. And the natural extension to that is to take that data and forecast on it. So it's the same as previous, we're forecasting demand, but this is just forecasting the data that we are exposing to our users. The image on the right here is from one of our clients that we worked with a couple of years ago. And here they are forecasting the weather. They're forecasting the path of the hurricane. And this is obviously a risk to your supply chain if parts of your supply chain are located in, the area where the hurricane is forecasted to land. So that applies to any sort of natural disasters, but you can also do the same thing for all of your other risk data, the financial weaknesses, company instability, entity of suppliers. So just going through a couple of those actually. When I say company instability there, so one thing that you can do, and one thing that the companies like Interos do, one of our clients, is that they attempt to obtain business information data, whether it be publicly or from third-party providers, and have all sorts of algorithms to automatically classify, detect, predict things that are happening to particular companies, and then apply that to your supply chain. So pretty neat use case. Something a bit closer to my heart is the software supply chain. So when we say supply chain, we kind of think of a supply chain as being a physical supply chain for manufacturing goods. But obviously there's a supply chain in a wide variety of other circumstances. And all of the ideas that I'm talking about today could easily be applied to them as well. So in the software supply chain, we have all sorts of, interesting and different problems that you might have. So the first one that I'd kind of like to point out is that firstly, it's probably quite easy to generate the supply chain for your software in the first place, because there's lots of tooling that exists to map out all of your supply chain, which is maybe not true for a more physical supply chain. But still, the sheer size of the supply chain makes this quite daunting. So you may have to apply some automated techniques to attempt to, detect some of these anomalies. And some ideas that you could look at is looking at libraries, the licenses of the libraries specifically. I had a case the other day, which there was a library I really wanted to use, but it was licensed AGPL, which is a software an open source software license that forces you to release your software, basically. So not great for companies. Another one is if you have some sort of vulnerability in a library deep down somewhere, like the Log4j vulnerability that happened a couple of years ago. That one led to lots of remote code execution in all sorts of popular software, like Minecraft, for example, because that's a very popular component in many libraries. So if you can flag those things automatically, if you can expose them, if you can have some analytics on them, then maybe you can avoid some of the impact that it might have. But these supply chains also exist in other contexts as well, like in your back office. So a classic recent one was all of your back office machines, IT, just doing your day-to-day IT tasks, and you've installed some antivirus, something like CrowdStrike on it. And of course, if your supply chain involves or includes something like CrowdStrike, and that causes an outage because of a bad update, then that's something that you need to be aware of, and you should be exposing to the rest of the business. So this isn't a word I particularly like, prescriptive analytics, but it's used quite often, especially in the supply chain context. So if you take your analytics data, so you've already exposed it, if you've already forecasted it, then what you can do is you can make decisions on that forecast. You can automate some of the decisions to be made that humans would normally be making. The reason for doing that is that if you can react faster, then you could save money, make money, again, finance. So there's a couple of use cases there. Walmart reduced their per unit costs by 20% by automating their fulfillment center. Interos found that reacting to disruptions in supply chains quickly can save lots of millions annually. Take these numbers with a pinch of salt, but I hope that kind of indicates a trend for automating some of the decisions. And I think the goal here is that we don't want to remove, we want to, how shall I put this? The goal here is to help people be more efficient, help people make better decisions when they need to make a decision. If they're making lots of routine, boring decisions, then they probably don't need to do that. You can probably automate it. But of course, in any good AI system, you need good governance, good oversight. So looking at the way in which we would do a project now. So let's move on to a little bit about how AI works, how you would run an AI project. This is quite a simple example. This has been around for quite a long time. I talked about it earlier. In the olden days, in the good olden days, in the black and white days, people used to decide which route that they would take to deliver packages. They would, use their knowledge of the city or whatever, their own internal knowledge to decide what route to take. Obviously, that turned out to be quite inefficient, and algorithms were written to optimize that route. But how did they do it? Well, the first thing is the data, and the data is the raw material of all AI projects. If you have good representative data, then it's quite likely that your project is going to succeed. So there's two main reasons why AI projects fail. The first one is that you haven't got a good problem definition, or you're trying to solve a problem that the business doesn't actually want solving. The second one is that you just don't have the data to make the decisions for the things that you want to do. So the data needs to be representative and it needs to be of high quality. If it is, then we can start tackling the AI problem by training a model to do what we want it to do. To do that, we need to convert that data into a format that is usable by the model. So, and that's domain specific and it's problem specific. For the route optimization problem, we need to split the data into a set of costs that each of the route segments would incur, the tasks, the jobs that need to be done, but also the fleet of the vehicles that we have to deliver our packages. Once we've split up and cleaned up all of that data, then we can actually optimize the routes to minimize some objective, in this case, which is probably cost. The training process uses all of that historical data to produce a model, and that model is then used to predict future routes. You can loop back and keep retraining that if you want to. And more sophisticated models might even learn on the fly, like using some sort of reinforcement learning or something. UPS did this very thing a few years ago, probably about 10 years ago now. And they're now saving 10 million gallons of fuel every year just by running this model. So it's a clear ROI there for that particular project. I was talking, mainly to people in the business information services, and so I thought I would include an example here. So one of the areas that I talked about earlier was trying to improve the fulfillment, or not the fulfillment, what's the word? Can't remember. Anyway, doesn't matter. One of the areas in which we can use AI is to automate some of the back office tasks, especially sort of accounts payable, contracts, and things like that. Especially if you're a business that has a large number of contracts with a large number of suppliers, it can be quite hard to manage. One thing we can do is we can analyze those contracts for particular elements of interest to your business. So again, this is how you would do it. You would take your contracts and invoices, you would feed them through a wide variety of data pipelines to chunk up the data, to split the data into various segments, maybe to build some kind of knowledge graph, maybe to link things together. And then we can feed that into AI models in order to extract pertinent information. That information can then be fed into some downstream system, like if you're analyzing contracts, maybe you're interested in looking for particular parts of the contract, like liabilities, for example. We can then use all of that past information to calculate how big our liabilities are for the use in the sort of the downstream business. In this particular example, I'm talking about invoice reviewing. So we could consider it as like an accounts payable like task. Most invoices look very similar, and you can pull out all the facts and figures and match them or reconcile them with figures that are already known to your system. And according to one piece of research, on average, account payable automation saves teams an average of £13 per each invoice processed. So if you're a big corporate and you're processing thousands of invoices a day, then potentially that's a big saving. All right, switching tack a little bit now. We've talked a little bit about the the potential use cases for AI. But I also remember that I'm talking within the context of business information providers as well. And a lot of the AI systems that we've been talking about, especially for our clients, we're developing these solutions, these bespoke solutions just for them, so we can run that on a variety of platforms, whether it be on your on-premise or maybe it's in your cloud. But yeah, that kind of brought me back to this idea of thinking about data security and data sovereignty. So increasingly for many supply chain businesses that are attempting to improve the supply chain, at least, it's their USP is their access to their data, and then maybe it's their proprietary data that nobody else has. You don't want to be handing out that information for free to your competitors. It's your IP. You need to look after that. And depending on your level of paranoia, you should be thinking about where that data goes, because as soon as it enters somebody else's system, then potentially it doesn't belong to you anymore. So for example, if you are using a third-party service in a different country, then that country's laws may not be the same as the laws in your own country. So, for example, there's the US Patriot Act, which in short gives the US government the legal capability to access any data it wants. There's some checks and controls over that, but effectively it could access your data whenever it wanted to. And that could be in violation of, it could be in violation of European law, could be in violation of like GDPR law, for example. But I mean, more realistically, it could be in violation of your principles, or maybe you don't want to risk losing your IP. I think that's a bit of an extreme example, but the different legal jurisdictions that your data resides in may be important. So that might be one good reason to host your systems in one particular jurisdiction. Another one might be that you don't want to hand your data over to a third party. So if you're using any third party, then your data is going through their servers, it's going through their software, it's being stored, it's potentially even being used. It's potentially being used to train their own models. Like if you're using one of the large language model vendors, for example. Another aspect is that if you're using a competitor's services, I mean, I'm not sure if you would, but if you do, then again, they would have direct access to your data. So one simple way of working around that is to host your software, your stack, your solution on hardware that you own. It could be on premise, it could be in your own cloud. And we're building a product called Helix, which is basically, give you the short version, I won't talk much about it now, but it's basically OpenAI, but on premise. So it's on premise or in your own cloud, connected to your own data, connected to your own systems, and it never connects to any external systems to do its job. So you can be sure and you can be confident that the data never leaves the security of your hardware. And so really that's one of the sort of the primary driving forces behind Helix. So if you're interested in looking for a large language model solution that you can run on your own hardware, then check out Helix. Okay, so starting to conclude now. So a couple of ideas, a couple of thoughts that have kind of run throughout this presentation. So the first one is, it's never been so easy to get started with AI, especially in supply chain. There's a wide variety of potential use cases that you can take inspiration from now. There's established patterns, and there's also established technologies that can help you as well, especially when it comes to working with language models, for example, because they're so easy to use. The interface to them is human text. They're so easy to interact with. So this is often a very good gateway, a very good interface to be able to expose some of your data. But I mean, that doesn't mean that traditional AI techniques are not useful anymore. They are, especially if you are interested in automating decision making, forecasting, things like that. One of the challenges that you might find if you were to implement a project like this, though, is the increasing amount of software that you have to manage and run and operate. So one of the services we provide is MLOps. That's the idea of attempting to build resilient AI systems that work in production and work at scale. But yeah, even for a small company, you know, the sheer number of components that are required to manage and to operate are it's getting challenging. Yeah. Well, so it might be interesting to take a look at your supply chain throughout your software stack as a first, you know, a POC of a supply chain analysis. Another thing as well that kind of related to this, not directly related, but relevant, is that regulation is upon us. So I've already mentioned the data aspects. So in most countries, we have to protect our data and be sure that we have controls in place to make sure that user data is secure. But this is also becoming relevant for AI in general. The EU AI Act, for example, is now signed. I've got a couple of other videos on this if you're interested. And yeah, we need to start taking care of the applications that we're building, the AI that we're using, and the use cases that we intend to deploy into production. So yeah, check out the regulation, keep up to date if you can. Lots more content on the website if you'd like to learn more about that. Okay, I think that's it for now. Yeah, that's it for now. So if you've got any questions, then please pop them in the chat. I'd love to answer them. I hope that's been useful. I wanted to, give you a little bit of inspiration about how AI is being used within the supply chain, how it could be used in the supply chain. There's a lot of opportunities here for companies if you're working within the supply chain itself. Yeah, I'd love to hear your thoughts, what you're doing. If you've got any questions about that, then yeah, you can either email me, Phil@Winder.ai, or just visit Winder.ai. You can find our information there, or of course you can ask a question now if you can. So apologies about the LinkedIn related issue. I honestly don't know what the problem is there. I can see that the event is live, but the video just won't play. So yeah. No idea. Oh, did my messages even get through? Oh no, they might not have done. Bother. Let me just put that there anyway. Yeah, YouTube is working fine. Oh man, I don't even think my comments have got through either. Okay, well, we're probably not going to get any questions because LinkedIn's not working. Well, if you're still here, thank you so much for figuring it out. I assume you're watching via YouTube or something now. But for everybody else that is not here, I'm very sorry. I will release the video on the website, and we'll share it on all our channels there, and then you can watch it again. All right, I'll just go quiet for a few more minutes just to see if anybody has any questions. Oh, nightmare. Okay, I don't see any questions. So if you're still watching, thank you very much. I'll publish this video on the website. If you've got any questions, reach out to us at winder.ai. Okay, thanks a lot. I hope you've enjoyed it. Bye-bye.